Hello there, and as we continue on in Chapter 3, we are going to be looking at 3.5 Day 1, which introduces us to our proofs with our parallel line and transversals. So the first thing we are going to talk about is how our given is if two lines are parallel. So that's our given for each one of these situations. That's what we start off with. And from there, based off the angles that are provided for us, we can make some new justifications. So if we take a look at our first example here, we have angle 1 and angle 2 provided for us. Our given again says that M and N are parallel, so we can give that some sort of parallel marking, so that way we know they are parallel. Our next statement says that 1 and 2 are congruent. So based off the location, we can say by the corresponding angles postulate that they are, in fact, congruent. All right. Next, we have our alternate interior angles theorem. Again, we're told Q and R are parallel, so we're going to leave those with a little marking that they are thus parallel. That is a part of our given. Our next statement that we are trying to justify is that 3 and 4 are congruent because they are both on the interior of our parallel lines on alternating sides of our transversal. We can say by the alternate interior angles theorem that this is true. These are real short and sweet. All right, for our next one, the alternate exterior angles theorem, A and B are marked as parallel in our given, so we're going to mark that on our image. We're trying to prove that 5 and 6 are, in fact, congruent. So because these lines are parallel, and 5 and 6 are on the exterior of our parallel lines, and on alternating sides of our transversals, we can say by the alternate exterior angles theorem that this is true. And then lastly, our same side interior angles theorem. So G and H are parallel, so we'll go ahead and mark that as well. That is our given. And it's trying to say that 7 and 8 are supplementary. So 7 and 8 are both on the interior of our parallel lines and on the same side of the transversal. So by the same side, interior angles theorem, we can say this is true. Oops, same side, interior angles theorem. All right.